Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 4th, 2025, just 2 days ago. It introduces Semantic-First diffusion, a new way to separate semantic structure from texture in diffusion models, reaching FID 1.06 and 1.04 on ImageNet 256 by 256, while converging up to 100 times faster than the original DT. The paper is titled Semantics Lead the Way, Harmonizing Semantic and Texture Modeling with Asynchronous Latent Diffusion. And as we will see later, the implications for how we train and speed up generative models are quite significant. Figure 1 shows how Semantic-First diffusion staggers semantics and textures over time, and why that schedule makes training much faster. The left side illustrates 3 stages where semantic latents denoise first, then guide textures, before textures finish alone, and the image is decoded only from the texture path. The small inset with the dog visualizes that final decoding step. On the right, the convergence curves reveal that adding this semantic-first schedule lets Lightning DT reach strong FID with far fewer training iterations, achieving over 100 times speedup versus plain DT and about 33 times versus standard Lightning DT. Figure 2 explains how the semantic VAE actually compresses meaning from a vision foundation model into a small, reusable code. The left stack shows a series of linear projections, transformer blocks, and layer normalization that first process the raw semantic features. On the right, a transformer encoder turns those features into a compact latent S1, and a transformer decoder tries to reconstruct the original features. The reconstruction uses both mean squared error loss and cosine similarity loss, which together encourage the latent to keep the important semantic structure while discarding redundancy. Table 1 and Table 2 together show that semantic-first diffusion keeps image quality very high while slashing training cost. The left table reports FID without guidance, where adding semantic-first diffusion consistently cuts FID scores for every DT size, so images look much more realistic. The right table compares guided models on ImageNet, and semantic-first diffusion matches or beats the best diffusion systems with about 1/20th of the training epochs. These results suggest that letting semantics lead is both more accurate and far more efficient. Table 3 shows that each ingredient in semantic-first diffusion helps, and combining all 3 gives the best image quality. FID, reflection inception distance, is a standard score that measures how realistic generated images look, where lower is better. Without extras, the model sits at FID about 8, adding REPA, and the semantic VAE drops it to about 5, and adding the semantic-first schedule reaches about 3. Table 4 then compares semantic compression methods and finds the semantic VAE beats simple p-century A. Table 5 confirms that applying the same semantic-first schedule to the read-die model also lowers its FID noticeably. Alright, the key takeaway is that letting semantics lead and denoising semantics and textures on staggered timelines makes diffusion models both sharper and dramatically faster to train. More broadly, it suggests that smarter representation schedules, not just bigger models, can unlock major gains in generative quality and efficiency. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.